In this video, we're talking about the idea of the understood x or the understood 1. You might hear it called both things. We're going to use a couple of examples to illustrate this problem before we talk about the theory behind it. So what I want to do is simplify a couple of these expressions, and they'll help us illustrate our point. So the first expression we have here is x plus 2x. And we know that we have here 1x, right? There's this understood 1 here. 1x plus 2x's is going to give us a total of 3x's. We added 1x to 2x's and we got 3x's. And we know that because we have this understood 1 as a coefficient in front of the x. 1 plus 2 gives us 3. We have 3x. If we look at this example here, we have x plus this fraction 1/4. Well, we have to remember that we have this understood 1 here. This is really x divided by 1, not just x. When we do that, it's helpful because now we can find a common denominator with our second fraction here. We want to look at the larger of our two denominators. We have 4 here. So if we multiply our first fraction by 4/4, so that 4 times 1 gives us 4 and we get a common denominator with our second fraction, then the result becomes 4x over 4 plus 1/4. And then when we add those fractions that have the same denominator together, we get 4x plus 1/4 is our final answer. With our third example here, we have x multiplied by x cubed. And what we need to remember is that we have this understood 1. This x term here is just x to the first power in the same way that this is x to the third power. So we have x to the first times x cubed. And remember, we have this exponent formula here where when we have like bases, in other words, when our bases are the same, the base of this is x and the base of this is x, but they're raised to different exponents, so x to the a, and we multiply that by x to the b, then the solution is x to the a plus b. We add those two exponents together in the new exponent. So we get equal to the same base of x, but then we say 1 plus 3, and we get 4. So x multiplied by x cubed is x to the 4th. Now the reason I picked these 3 examples in particular is because when we look at what we've got implied here, we have an implied 1 as a coefficient, we have an implied 1 in our denominator, and we have an implied 1 in our exponent, and we call that the understood 1 or the understood x. And what that tells us is that 1x raised to the first power divided by 1 is just going to be equal to x. They're exactly the same thing, and that should make sense to us because if we process this fraction here with order of operations, what we're going to get is x to the first power. We're going to do that exponent first. So x to the first power is just x, so we're going to get 1x over 1. Then we do our multiplication and division. When we do our multiplication in the numerator, we get 1 times x, which is just x, so we have x over 1, and now we do our division and we say x divided by 1 is just x, so we say this is equal to x. So 1x to the first power all divided by 1 is just x, and that's what we have to remember is when we see just x here, and just x here, it's not just x. It's actually x with a coefficient of 1, an exponent of 1, and a denominator of 1. And we have to always remember that when we have that x, we can apply the coefficient, the exponent, or the denominator whenever we need to. In this first problem, we needed that coefficient. In the second problem, we needed the denominator, and in the third problem, we needed to remember that the exponent was there. So the point of this video is always remember that whenever you see this x here on its own, it's not just an x by itself. It has these implied 1 coefficient, exponent, and denominator.